Hello, class. Today we're going to start chapter 1, what we're going to do is we're going to go back and forth. This here is a drawing area where I'm going to draw some example problems and things that I think will help you in lecture. And then over here, PowerPoint, I will pull up to kind of go over some of the material. So the first part of this lecture, we're going to go over matter. Matter is composed of atoms. Atoms, at one point you could see here, the Greeks thought atoms were indivisible, meaning, you couldn't divide them. It was the smallest form of matter. It's as small as you could get. Well, they found that actually matter goes into smaller components. We know these as electrons, protons, and neutrons. And that's what an atom is made of. Okay? The electrons are negatively charged. So if I draw this over here, let me bring this over here. So we have electrons. We usually abbreviate this like E with a negative. That's a negative charge. These are very, very, very small, like 1 times 10 to the negative 19th. I mean, almost 0. And actually, usually we can pretty much consider it 0. So those are electrons. And in the atom, there's also protons, kind of P for proton. This is a positive charge. And then neutron, and these are neutral. If we look at the atom, if I have a circle here, okay, the electrons are on the outer side here. Electron, 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 electron. And then in the center here, this is called the nucleus. Okay, and let me get another color. Oh no, maybe blue. Okay, blue. Back over here. These are protons in here. Proton, proton, and then we have some neutrons. Let me make the neutrons maybe like a red color. Bring this over here. Neutrons, neutrons. Okay, so here we go. So the nucleus is kind of like the sun in the solar system, and the electrons are orbiting outside of this like the planets, if you want to use that analogy. Okay, so remember, electrons, negative charge, are on the outer part of the atom. Protons, they are in the center, and they have a positive charge, and neutrons are neutral, and they're also in the nucleus, in the center here. They're neutral. Most of the weight of the atom, 99.99999% of the weight of the atom, comes right here in the nucleus. So it's really the protons and the neutrons that really make up the weight or the mass of it. And the electrons are almost 0. And what's amazing is most of chemistry, we're actually looking at electrons, not really protons and neutrons. So all of the bonding and everything you associate with chemistry all deals with electrons. But the mass is where we have the protons and neutrons. Okay? So let's go back here. Oh, and this is an atom. So if you want to say an atom, like a carbon atom, this is, what we're talking about. We're talking about what are the electrons, protons, and neutrons that make up a atom. And if you look at a periodic table, you have like carbon, nitrogen, oxygen, fluorine, bromine, magnesium, all of those are the elements, which are basically all of the atoms we know of. Okay, so those are the atoms, and they compose of they're in the periodic table. Okay, those are the elements, which are the atoms. Okay. So again, each atom is unique. Each atom has its own number of protons, neutrons, and electrons that make it up. So a carbon atom has a different number of proton, neutron, and electrons than, let's say, an oxygen atom. It has a different number of electrons, protons, and neutrons. And if we want to go even further, you can actually divide electrons, protons, and neutrons up into what are called quarks. So, how do you get a charge on these, and how is a proton, how do you get the mass of that? Well, those are quarks. There's like up quarks, down quarks, calm quarks, all sorts of quarks. And those actually make up protons and neutrons. And so you can go on. There's all sorts of, well, we can break this down into this and this into this, and there's so many ways to break, components into smaller components. But for the most part for this class, what we need to know is that the atom is made up of a unique number of electrons, protons, and neutrons. If you do want to know more about, quarks and, well, what makes up an electron? Well, what makes up a proton? What makes up a neutron? If you read this article right here, it's really interesting and you might, enjoy it. It even goes over the God particle, which is the Bose-Higgs particle, and why is that called the God particle? And it basically has to do with mass. Anyway, it's very interesting. Molecules, these are made up of atoms, okay? So we have our periodic table, and let me pull up a periodic table just so we can see one. Okay, periodic table. Let me pull up this one here. So all of these elements are the different atoms that we can have. So, there's nitrogen, oxygen, fluorine, chlorine, sulfur, phosphorus, magnesium, calcium, vanadium. All of these are possible atoms, okay? A molecule is whenever you start combining those atoms. So here's an example here, H2O, which is water. Do you see that I have 2 hydrogen atoms? So do you see 2? Right here, the subscript, that means I have 2 of the hydrogens, and you see that there's not a subscript here, so that means it's 1, it's implied 1. So I have 2 hydrogens, 1 oxygen, but do you see that I combined a unique ratio of oxygen and hydrogen atoms? And that's a molecule. Their properties depend on the composition of them. So for example, let's compare carbon monoxide to carbon dioxide. So if I come over here, let me get a new one. Okay, so I have CO. Okay, now let's think about this here. What atoms makes up carbon monoxide? That would be carbon, there's a carbon atom, and an oxygen atom. Okay? Now how many of each? Do you see that there's no subscript there? So that means 1. So there's 1 carbon, 1 oxygen. Now let's come back over here. Versus, sorry, I don't know why that came out weird. Okay? CO2. Now, what atoms make up this molecule? Do you see that it's still carbon and oxygen? So both carbon monoxide and carbon dioxide are made up of carbon and oxygen, but the ratios are different. So this has 1 carbon, 1 oxygen. This has 1 carbon, 2 oxygens, okay? But they're still just made up of carbon and oxygen. Okay, now let's look at the different properties here. Carbon monoxide. Everybody knows that, carbon monoxide can kill you. It's called the silent killer. Why? It's colorless and odorless. We can't smell it, we can't see it, and you can die of carbon monoxide poisoning, mainly because it binds to hemoglobin instead of oxygen. So hemoglobin brings oxygen to your brain, to help you keep you alive, all right? But instead, this will bind to it, so now the oxygen cannot get to your brain. Okay, so if we look at carbon dioxide, now just adding 1 more oxygen there, it's still colorless and odorless, okay? But this does not combine to hemoglobin, so it will not kill you like carbon monoxide will, okay? So just adding this 1 extra oxygen here, having 2 instead of 1, the difference is death, really, if you think about it. Now, that's a pretty drastic difference there, but just to show you, you change 1 thing about a molecule, and they'll have, completely different properties. This is pretty important to keep in mind here. All right, so let's go to the next slide, and this is really what defines chemistry here. Basically, we're in chemistry, we're looking at different ways to combine atoms to make new molecules and compounds. Okay, so we have the periodic table. We're trying to find what unique combination of those elements slash atoms can we make to make a new molecule. Okay, and that's what chemistry is. We want to make these new molecules and study them. What observations do we make? Are these good, bad, so forth. So hopefully that gives you an idea what chemistry is. We have these atoms, which are composed of protons, neutrons, and electrons. Okay? And what we do is we combine these atoms to make molecules. So that is your first lesson today. So start thinking, what is a compound? What is an atom? What is chemistry? These are the things that are you need to review on for your exam.